Welcome class to our video notes on skills 2 and 3 from unit 3. These notes will cover the skill for simplifying rational expressions as well as identifying restricted values for the variables in those expressions. The steps are fairly straightforward. Basically, we're doing a lot of factoring. We're going to have to factor the numerator. We will then factor the denominator. At that point, we can look and see what restrictions we have because we have to restrict any values that will make the denominator 0, and to find what those values are, we factor the denominator and solve it by factoring. But then our ultimate goal for simplifying is to basically cancel out any common factors. Okay, that's the key word. We're canceling out common factors between the numerator and denominator. What makes factor a key word is that it implies multiplication. A factor is something being multiplied specifically to something else, not added or subtracted. So what are we doing when we cancel? We're dividing, okay? When you cancel out something, we use the word cancel, but really what we're doing is we're dividing identical quantities that are equaling 1. That's what it really means to cancel, okay? So, for example, let's look over here at number 1. I'm showing you I want you to compare what's going on in these two things, right? This is the operation of addition, okay? If I add 3 to the number 7, I change the nature of that number. The act of adding something to another number will change its factors. See, right now you might think, oh, I have 7 over 7, right? 7 divided by 7 is 1. And then I can cancel that, right? We might think, oh, I can cancel that and it equals 3. But the reality is that's not what it equals, right? Adding 3 to 7 actually equals 10. And the factors of 10 are not 3 and 7. The factors of 10 are 2 and 5. So the simple act of addition changed the nature of the number, giving it two different factors, neither one of them being 7. So actually 10 does not divide evenly by 7, right? 7 doesn't fit evenly into 10, and the result is not 3, right? So addition, adding two things, means you cannot consider 7 a factor. It's not a factor, right? 3 plus 7 created two completely different factors. Whereas, right, versus this scenario where it's the act of multiplication. The operation is different, right? I'm multiplying 3 to 7. And so the factors of that result are 3 and 7, right? Because that produces 21. The factors of 21 are 3 and 7. So that act of multiplying meant that these numbers were factors of whatever number was about to result. And so in that sense, you can say, oh, 7 is a factor of the numerator. I can cancel it, right? I can cancel that out. And the answer to this is 3. 21 divided by 7 does equal 3, right? 7 fits into 21 3 times because it was one of the factors of 21. It divided evenly into 21. And so that's, why multiplication is the thing that indicates a factor. Okay, but what are we doing when we're canceling? We're recognizing something. We're saying 7 divided by 7 is 1. That's essentially what we just did right here. We said, okay, 21 consists of the factors of 3 and 7. And 7 is a common factor with 7, right? 7 divided by 7 is 1. So the only factor that remains when I try to divide 21 and 7 is 3. So that's why 21 divided by 7 is 3. That's essentially what we're saying. 7 divided by 7 is 1. It's an identical quantity. Okay, this is with numbers. Over here, I wanted you to take a look at it with binomial factors, which was something we had looked at in Unit 2. Right here, it's very tempting. When students see a rational expression like this one, they quickly want to cancel the 4s because they see, oh, 4 over 4 is 1. But this is not 4 divided by 4. In fact, this number is not even really 4, okay? Because it's being subtracted from something else, right? This is whatever 3y is minus 4, which will change the factors of 4. And whatever this results in will have two completely different factors, right? Just like over here when I did 3 plus 7, the number that resulted, 10, had two totally different factors that it wasn't even a 3, right? They were neither 3 nor 7, because when you add two numbers together, it changes the nature of that number, giving it different factors. The same thing is happening here. So actually, this cannot simplify. This would already be in simplest form. Whereas this one over here, there's the active multiplication going on right here, right? 3 is being multiplied to the quantity y minus 4. That means 3 is a factor, and this binomial y minus 4 is the second factor, right? If I multiplied this out, I'd get 3y minus 12 over y minus 4. And 3y minus 12 consists of the factors of 3 and y minus 4. So these two things, the single number and the binomial, are the two factors that make up the numerator. Turns out there's an identical factor of y minus 4 in the denominator. Those can cancel because y minus 4 divided by y minus 4 is equal to 1, because this is the same thing divided by itself. It's kind of like thinking about it this way. How many times can y minus 4 go into y minus 4? It can go in one time, right? 1. And so that's really what we're saying when we cancel. We're saying, oh, these are canceling out to equal 1. So then this would just equal 3, right? 3y minus 12 divided by y minus 4 is the same thing as 3 times the quantity y minus 4 divided by that identical quantity y minus 4. Those divide to equal 1. We say they cancel, and I'm left with 3. And this would be true because y minus 4 is a factor of the numerator. This does not divide to equal 3 because they don't have any common factors, so you just leave it as a fraction. So in example 3, we kind of see, again, a situation where it's like super tempting. We want to just say, oh, okay, 5 goes into 10 twice, and m's cancel out, and therefore I'm left with, 1 over 2 plus 2. I get 1/4. Done. Okay, no, that's completely false, okay? That's not how this works. Only common factors can divide to equal 1. The reality is that 5 is not a factor of the numerator because it's being added to some value m. And so once you add 5 to some other value, it's going to make whatever number results have different factors, and 5 may or may not be one of them. So I can't just go cross-canceling things like that. I have to look for common factors. Well, in the numerator, there really is only one factor, m plus 5. And I just want to say one thing. Even though it's not written, we always recognize 1 is always there, even when you don't see it. So technically, 1 is a factor of the numerator, and then m plus 5 is the other one. In the denominator, we want to look for a greatest common factor between the two terms, and that happens to be 2. So I can factor out a 2, and I'm left with m plus 5. So now I recognize, see, now that the operation is multiplication in the denominator, not addition, I recognize, oh, there is a common binomial factor. Both the numerator and the denominator have a common factor of m plus 5. And if you divide m plus 5 by itself, it will equal 1. It cancels out, right? We say cancels out to equal 1. And so what I'm left with is 1 divided by 2. Or 1 times 1 divided by 2 times 1, which equals 1/2. So that is what the value of this fraction equals for all values of m except for 1. So that's the other thing we have to keep in mind, are these things called restricted values. So the restricted values come from anything that turns the denominator into 0. So what we should do is we should take that denominator, we ignore everything else, we take the denominator and we set it equal to 0 because we want to find out what value of m is going to make this 0. So then we solve for m, and that helps us answer that question. So I subtract 10, I divide by 2, and I get -5. The value of -5 is a no-no. Because if m equals -5, if I plug -5 in here, I get -10 plus 10, which would cause me to be dividing by 0. And dividing by 0, let me just do this over here, will not exist, right? Does not exist. I'm not allowed to divide by 0. So these two quantities will divide to equal 1/2 as long as the variable m never equals -5. Then everything is good to go. So we simplify, but when we simplify, we just make a note, a comment like, okay, this equals 1/2 as long as m does not equal -5. Let me kind of illustrate this using Desmos. So if you go to desmos.com, and I'm going to use the variable x because that's what Desmos uses. If I were to graph x plus 5 and then divided by 2x plus 10, you can see, oh, actually, yeah, this fraction, if you look at the graph of it, it equals 1/2 like all of the time, right? In fact, I can get a point along here and show you the y value is just staying constantly 0.5, right? It's not changing from the value of 0.5 except when I get to -5. Whoa, there's a hole in the graph. The y value just doesn't exist right there because when m or x is -5, then I end up dividing by 0 and y doesn't exist. Y is undefined when you divide by 0. So, you know, it's an exception to the rule, right? The rule says, look at this, all these other y values are 1/2, all the way up and down, except for right there. So it's kind of like a restriction or an exception to the rule, so we have to state it. Looking at example 4, I can see, okay, now I've got a quadratic equation, right, divided by a linear equation. And if you recall from chapter or from unit 2, when we have something like something with 3 terms, right, we called it a trinomial, where the highest power was 2, it was a quadratic trinomial. We used trinomial factoring, where we would multiply a and c together, write b down, and find 2 numbers that multiply to 5 and add to 6. So that would be 5 and 1. 5 times 1 equals 5, and then 5 plus 1 equals 6. So that helps me figure out my factors for the numerator. So this is equal to n plus 5 times n plus 1, all divided by n plus 5. Because we're basically just looking at the factors, right? We start by factoring the numerator, factoring the denominator, and oftentimes our factors will be binomials. In fact, it helps if all you have is a binomial. You should put parentheses around it because that helps us remember that these have to be kept together. These are not separate factors because they are being connected by addition, right? So n plus 5 will have factors that do not include 5. Their factors will be different, right? When you add 2 things together, it completely changes the nature of those quantities. So 5 is not a factor of the numerator or denominator. N plus 5 altogether is. But it's a common factor, right? There's a common factor of n plus 5 in both the numerator and the denominator. And if you divide an identical quantity by itself, that will equal 1 because n plus 5 goes into itself 1 time. So when you divide them, they equal 1. So we think of that as canceling, right? So then this ends up being n plus 1 divided by 1, which when you divide a number by 1, it just equals itself. So n squared plus 6n plus 5 divided by n plus 5 is equal to n plus 1, right? That's what it equals. So long as, now we have to find the restrictions, so we can't let the denominator equal 0. So I start by setting the denominator equal to 0 and asking myself what value of n would make this 0. I can find by solving the equation. -5 would make it 0, therefore n cannot be -5. If n is -5, then I end up with a value that's undefined, right? I'd have a 0 in the denominator. So again, we can look at that on Desmos. But again, I'll be using x instead of n. So it's x squared plus 6x plus 5, and then all over x plus 5. So what you can see is a line, right? The result is a linear function, which makes sense because this is n plus 1, right? N to the first plus 1. So it's like a linear function with a slope of 1 and a y-intercept of 1, right? So when we look at the graph, that's what we're looking at, right? The slope of 1 and a y-intercept. Here's a y-intercept of 1, and then it goes up 1 and over 1 from there to get to the other points. So that's what these y values are that you're looking at. They're all the values of n, or x, plus 1, right? So when x is 2, y is 3. When x is 3, y is 4. When x is 4, y is 5, right? So the values of this fraction equal 1 plus n. Okay. Except when you get to negative 5. When you get to negative 5, there's that undefined spot again, that hole. So that's why it's an exception. It's a restriction. We have to restrict the value of negative 5. So this will reduce to equal n plus 1 as long as n does not equal negative 5. So the thing with numbers 5 and 6, so 5 and 6 have multiple variables. So sometimes this will happen when we're just thinking of these in terms of rational expressions. We'll have multiple variables we'll have to keep in mind. You also might see things like this, 6x squared y, 16m to the 4th n squared. This is just showing us one large product. So these are already all being connected through multiplication. So maybe I'll just kind of illustrate that. I'm not really factoring, I'm just kind of showing what this is. This is one long product. Meanwhile, in the denominator, I have a binomial again. So I need to think about how to factor it. And so I'm going to look for GCFs. And one of them is 3 and the other one is x. So I'll take them out together, 3 and x. And then from the denominator, I'll be left with an x plus 3 as the binomial. And to check that, you could just distribute 3x, right? And you get 3x squared plus 9x. So this equals that. Okay, so what we notice is there is 2 common factors I can reduce. I have an x over x, right? X divided by x equals 1. And then I have 6 divided by 3, which will divide to equal 2, right? 6 divided by 3 equals 2. So I can cancel 6 and 3, and it leaves me with 2 over 1. Right? 2 over 1. And I can cancel x, and it just leaves me with 1. So what I notice is that I'm left with a 2 in the denominator, 1x and 1y. I'm sorry, in the numerator. A 2 in the numerator, 1x, 1y in the numerator. In the denominator, both the 3 and the x went away and were replaced with 1s. And then I have the binomial of x plus 3. So 6x squared y over 3x squared plus 9x simplifies to equal 2xy divided by x plus 3, but we have to think about what our restrictions are. So I just take my 2 factors in the denominator and set them equal to 0, both of them. So the first one was 3x, set that equal to 0, divide by 3, x is still 0. And then the second one, x plus 3, set that equal to 0, subtract 3 from both sides, and x is equal to negative 3. So these are my 2 values that x cannot equal. These are my 2 restricted values. So as long as x is not 0 or negative 3, then we're safe. We won't have to worry about dividing by 0. And this fraction can divide to equal this one here. Similarly, in example 6, actually everything here was connected through multiplication. So you can just think of this as 16 times m, n, and n. You don't have to write this out when you're doing your practice problems. I just want to show you that's really what this is, right? It's 4 factors of m being multiplied together, 2 factors of n, and a factor of 16. And then I've got 48m and then 5 n's. So anytime you have one common factor over itself, it reduces to equal 1. So m over m reduces to be 1, right? So then that just leaves me with 1. And then n over n, and then n over n again, right? N over n equals 1. Any common factor over itself equals 1. So I'm left with 3 factors of m and then 3 factors of n. And then 16 can go into 48 3 times, right? So maybe we could think of 48 as 16 times 3. We could factor the number, right? Sometimes that's helpful to factor the number just to see, does 16 go into 48? Yes, it does, right? And 16 divided by 16 is equal to 1. So that's a common factor that we reduced. We canceled from the numerator and denominator. And so then I'm left with a 3 in the denominator, right? Because that's what was there originally. So then my simplest answer would be to have just 3 factors of m in the numerator. So I can write that as m cubed. 1 factor of 3 and 3 factors of n in the denominator. M to the 3rd over 3n squared would be the simplified version of this rational expression, as long as, so here are my factors in the denominator, right? I've got 48, I've got m, and then I've got n to the 5th, or 5 n's basically. Well, I don't need to worry about 48 being 0, so that's not a problem. But I can't let m be 0, and I can't let n to the 5th be 0. And if n to the 5th can't be 0, I could do like a 5th root here, right? Cancel that out, boom. Then n can't be 0. So basically those are my two restrictions for this one, because I cannot let any factor in the denominator be 0. And again, 48 was not something I had to worry about because it's clearly not 0. But m can be different things, so I just can't let it be 0. And then n to the 5th, if n were 0, then n to the 5th would be 0, and so I can't let n be 0 either. So number 7 is going to be a little more complicated because the factoring's harder, right? In the numerator, I have a quadratic expression again with 3 terms. So that's the kind that would require trinomial factoring, except this time the a value isn't 1, so the process is going to take a little longer. So I multiply a and c to get negative 42, and then b is negative 1. So I need to find 2 factors of negative 42 that at the same time when you add them equals negative 1. So that would be negative 7 and 6. And then I have to do the whole grouping process. So I'm going to do that off to the side over here so as to, not have all that work clutter this part of the graph. And so we group the first 2, group the last 2, take out an x, and I get 2x minus 7. Take out a 3, and I get 2x minus 7. And then I take out the common factor of 2x minus 7, and I'm left with x plus 3. So those are my factors for 2x squared minus x minus 21. So I will write that out. I factor the numerator into these two things, 2x minus 7 and x plus 3. And then in the denominator, I have a difference of squares, right? A difference of squares. 9 minus x squared is in the same form as a squared minus b squared, where a would be 3 and b would be x, right? 3 squared is 9 and x squared is x squared. So the factors of a squared minus b squared are a plus b and a minus b using the formula for difference of squares. So for 9 minus x squared, it's 3 plus x and 3 minus x. So that's what I get when I factor 9 minus x squared. Well, the order of addition doesn't really matter, right? X plus 3, 3 plus x is the same thing. So I can cancel those factors to equal 1. So x plus 3 divided by 3 plus x is the same thing as saying x plus 3 divided by x plus 3. And so it's the same quantity divided by itself, so it will equal 1. Therefore, I can cancel it. So then my simplest answer for this one would be 2x minus 7 over 3 minus x. That is my simplified answer for this equation. So long as x is neither 3 nor negative 3. And that comes from these two factors. Or I should say over here for the denominator, those two factors, right? I'm not allowed to let the denominator equal 0, so I take each of those factors, set them equal to 0, and solve for x. So the first one tells me that x can't be negative 3, and the second one tells me that x can't be positive 3. So that's my restrictions, and there's my simplest answer. So last but not least, we've got number 8. And again, the factoring gets a little bit more challenging because I have a x to the 3rd. So that's going to require something from Unit 2b. Now remember, when you're factoring, you always want to look for a GCF. And I notice in the numerator, I've got a GCF of 2. So I'm going to factor that out. So 54 divided by 2 is 27. Okay, so I took 2 out of the numerator. In the denominator, I notice a GCF of 5. So I'm going to factor that out, and I get 5 times the quantity x minus 3. Okay, so 2 and 5 can't cancel, but I am noticing something about the x cubed minus 27 and the x minus 3, and I'm wondering if maybe I can factor x cubed minus 27. Any ideas what this might be? Can you remember? Does it remind you of anything? Well, this is a difference of cubes. So don't forget those formulas. Hopefully some of you, still have them in your minds. I don't know. But it follows this setup, right? This is in the setup a cubed minus b cubed. And the formula for that is it will factor into a minus b times a squared plus ab plus b squared. This is our difference of cubes factoring formula. And in this scenario, a would be x and b would be 3 because x cubed is x cubed and 3 cubed is 27. So I'm going to factor it according to the difference of cubes formula. So the first factor would be a minus b, which in this case is x minus 3. And then the second factor has 3 terms, x squared, which in this case would be x squared, ab, which in this case would be 3x, and b squared, which in this case would be 3 squared. So that's the numerator is factors into these 3 things. So this little tiny 2x cubed minus 54 actually factored into these 3 factors. Meanwhile, the denominator was already completely factored before. All it had was a GCF of 5. But I'm noticing a common factor of x minus 3, right? X minus 3 divided by x minus 3 is equal to 1. Therefore, I can cancel it out. So it turns out those numbers actually didn't reduce at all. So we can either leave them factored out or we can distribute the 2 back in, either way. But those numbers need to stay where they are. So the numerator is left with a 2, and then x squared plus 3x plus 9, and the denominator is left with a 5. So this is my simplest form of number 8. This is the simplified version of number 8. Now, I cannot let 5x minus 15 equal 0, though, right? I cannot let that happen, because if that happens, this value is undefined. So I just set it equal to 0 and solve for x. So basically, I just cannot let x equal 3, right? So this will reduce to that as long as x is not equal to 3. So on your outline, there are 3 for you to try, okay? Some simpler, others harder. I want you to pause the video, try these, and then check back and see how you did. Okay, for number 7, the final answer ends up being 1 divided by m minus 3. That's the simplest form. And the excluded values end up being negative 7 and 3, because when you factor m squared plus 4m minus 21, you end up with one factor that says m plus 7 and then the other one that says m minus 3. So these would be the numbers that make those 0, so they're excluded. And then the m plus 7's cancel, leaving a 1 in the numerator. So you end up with 1 over m minus 3. For number 8, the only thing that you can do for both numerator and denominator is factor out a GCF. So there was a GCF of 35 in the numerator and then just 5 in the denominator. And 5 can divide into 35 7 times, leaving a 7 in the numerator. And then the binomials just stayed because they weren't in common, so there's nothing else that can cancel. And no, you can't cancel those x's because they're being subtracted by another number, which is changing their factors. So this is your final answer. And then if you set this factor of 5x minus 8 equal to 0, it tells us that x cannot equal 8/5. If I plug 8/5 in for x, I get a 0 in my denominator. For number 9, it was a difference of squares in the numerator and then a difference of cubes in the denominator. So I used the 2 formulas, the difference of squares and the difference of cubes. And when I did that, I had a common factor of x minus 2. So I was able to cancel that out. But that's all I can cancel out. I can't cancel this x, and I can't cancel that 2 with that 4, because this is really not a 2. It's x plus 2, which would have different factors, and it turns out it doesn't have any factors in common with x squared plus 2x plus 4. So this is the simplest answer. The simplest form of this fraction is that. And then if you set the denominator equal to 0, this would give you a value of 2 for x, and then this would give us 2 imaginary answers, but we don't need to exclude imaginary answers because they're already excluded by the domain, right? With the domain, we always say all real numbers, which means to say no imaginary numbers. So they're already sort of excluded. We don't worry about those. But if x did equal 2, which is a real number, that would make the whole denominator equal to 0 and therefore has to be excluded. So I will see you in class tomorrow where we will do lots of practice with factoring and canceling and finding excluded values, and I'll see you there.